What is up, CSUF physics students? Today, I'm going to be talking a little bit about your first online physics lab. It's going to be a little introduction to using a new tool that we're introducing for this summer and potentially for fall, depending on how things are going with the outbreak. Pivot Interactives. Um, so this is an online lab tool that effectively uses us to watch videos of experiments and use certain tools, rulers, stopwatches, protractors, to take measurements and to sort of have a meaningful online lab experience. Instead of just the end of last semester, we were just sending data out for our labs, and it wasn't as fulfilling an experience in terms of like a lab. A lab, you want to come in, you want to do an experiment, you want to play with tools, you want to get your hands on stuff. So this is sort of as hands-on as we can get during the outbreak, unfortunately. But we're gonna make the best of it. So this, our first lab, should be assigned to you by your instructor. You should be able to find it under My Classes. Click on your lab class, and then this will be your first assignment that's assigned to you. Here I have it in my library, so I'm just going to go ahead and preview it, and we'll talk about it a little bit. So the idea of this lab is it's not really about physics, although hopefully you'll learn or use some physics here, but it's about getting familiar with these tools. So in Pivot Interactives, there's going to be a video of an experiment. These experiments are going to vary. This is a simple one that's just about 1D motion. But it's cool 1D motion. It's a ping pong ball cannon. We've actually built one of these. It's super cool. High pressure cannon shoots a ping pong ball, blows up a can. It's awesome. What we want to do is we want to use image analysis to view the motion of this ping pong ball. What's its speed? Is its speed constant? Is it changing? How long does it take for this collision to happen? There's any kinds of questions that we could ask, and we're just going to be playing and pausing, and we can go through frame by frame and analyze this video really, really quite well. And the great thing about Pivot Interactives is also you can click the information here to see a few of the video playback tools. But what we're really going to be focusing on is these tools up here on the top right. So you can see you can drop a stopwatch, and you can drop a ruler. You can drop points. So you can mark, okay, this is the position of the leading edge of the ball. And then you can skip frames. Oh, okay, now sometime later, here's the next position, leading position of the ball. You don't need to use these dots. They're there as a tool for you if you want. But what you will need is the ruler, stopwatch. You may need additional tools for additional labs. For part 2, I have you use a protractor to measure angles of reflection of a laser off of a plane surface. But for this lab, what you need is a stopwatch and a ruler. These rulers are pre-calibrated for the video. So what they usually do is they set up their experiment and they know that the distance from here to here is some amount, and then they calibrate the ruler that you're allowed to drop on the screen. So we know that this is accurate with the position of the ping pong ball, so we'll be able to get accurate data. Otherwise, if it wasn't calibrated, you wouldn't know. You can adjust the angle of this, so you'll want it to be as horizontal as possible to be accurate. And then the other cool thing that you can do is you can set 0 positions, right? So ideally, the first place I'm going to be taking measurements, I kind of want to set that as my 0 because it just makes all my other calculations easier. If I set it at like, oh, I'll set the leading edge of the ball at 6 centimeters and the time at 0.0654, then I'm going to have to deal with those two constants the whole time. Not ideal. So what I'd like to do, I'm going to 0 out my ping pong ball, and I can also 0 out my time. Set this frame to 0, and now I'm only going to be counting forward going on. So very powerful tools to be able to 0 out like that. And then it has you go through, do some analysis using these tools, answer a few simple multiple choice questions, and then it has you take data. So in Pivot Interactives, they have built-in data tables and plotting, which is really, really cool. You can do it all in one place. I know that some instructors may have you use something like Google Sheets or Excel to do the analysis outside of Pivot Interactives. However, we do have the power, or you do have the power to do all of the analysis in Pivot Interactives. So I can call this like position, call it X, in the units up there were centimeters. You may want to do it in meters, it's up to you. I'll insert another column. We'll look at the time too, that'll be in seconds. And then I could take data here because I'm able to measure the position and I'm able to measure the time. Guess what? Position versus time. Oh, I can plot that, and I can analyze the position versus time plot of this ping pong ball, and I can use that plot to calculate things like the velocity or just learning a little bit about the motion. And if you haven't covered enough physics to go over this point in your lab, make sure you talk with your instructor. This is mechanics 1D motion. This is the first lab, so if you haven't covered it in class yet, then make sure you work with your instructor. And then you tell the plotting, you tell them which of your variables you want plotted on the horizontal and the vertical. Since time is always independent, that's going to be our horizontal axis, and position is our dependent variable. In this case, we'd make that our vertical axis. And you can also plot a second set of data, which is cool. So you can have like 2 plots. And then it has you answer some questions. And this next part, there's a video. This actually has some audio of them spinning the bike wheel. But basically, they just shine a laser at a plane mirror, and then we look at the angle at a few locations. So, and for this one, the tools that are available, you can see is a protractor, and you'd want to drop it so that's there. Again, make sure that it's reasonably straight up and down. This is just like any experiment, it's just like measuring with a protractor. If you mess it up, if you're like taking measurements like this, you might, your number's going to come out a little bit different. So try to set up your tools as accurately as possible. Just like if you're measuring something with a ruler, you want to try to measure as accurately as possible. Use the grid lines, and then you can just take a few data points here. And it has you do a table and then just do a little bit of analysis about it. But make sure that you label your columns, their units, and everything like that. So this is just an introductory warm-up lab, just getting used to using the tools. These are the tools that you're going to be using for our labs over the summer. This is what we've decided to do for our hands-off laboratories, trying to give you still a bit of a hands-on experience, actually taking data, actually doing meaningful analysis of meaningful data. So there's some really, really good experiments we have set up for you over the semester. We're really, really excited about it. We may have to be doing this in fall. You're going to be the first people doing this with us, so you're our guinea pigs a little bit. So we'll really be looking at your feedback at the end of the summer session. But I know that you all are going to do great. You're all going to be working hard. It's going to be a really, really great summer. I hope that you and your families and friends are all staying super duper safe and just making the most of this time we have at home to spend with with family and friends and everything. But anyway, hope you're all well. I'm looking forward to seeing some good data and analysis on this first lab, and looking forward to an excellent summer. I'm Bobby Wright. I'm a technician in the department. If you have any questions, your instructor will be able to reach out to me, or he or she can give you my contact information. But anyway, thank you very much, and talk to you soon.